Welcome back. Today is the most famous and most debated design pattern, the singleton. It ensures a class has only one instance and provides a global access point. Love it or hate it, you need to understand it. Let's look at both sides. Imagine your app connects to a database. Different modules each create their own connection. const_con1 was the new database connection localhost 5432. const_con2 said new database connection localhost 5432. const_con3 requires new database connection localhost 5432. 3 separate connections to the same database. 10 modules means 10 connections doing what one could handle. This wastes resources and they can conflict. One writes data while another reads stale data. The singleton pattern does 2 things: makes the constructor private so nobody can call new directly, and provides a static method called getInstance that creates the instance on first call and returns that same instance forever after. Think of a country's government. There can only be one official government at a time. You don't create a new one. You access the one that exists. That's a singleton. Here's the classic TypeScript implementation. We start with a static property to hold our single instance. The key is the private constructor. This prevents any code outside the class from using the new keyword. Next, the getInstance method. It checks if an instance already exists. If not, it creates one. This ensures the connection is created lazily, only when it's actually needed for the first time. No matter how many times you call getInstance, you get the same object. DB1 and DB2 are identical. In modern TypeScript, there's a cleaner approach. Modules are natural singletons by nature. You can define a regular class without all the boilerplate, just a standard constructor and methods. By exporting a single instance from the module system itself ensures this code runs only once. In any other file, you just import that shared instance. It's cleaner, more idiomatic, and very effective. Now the controversy. And it's real. Singleton is often criticized for several major reasons. First, it violates the single responsibility principle. It manages both its own logic and its own instance lifecycle. It makes unit testing harder. You can't easily replace the singleton with a mock for isolated testing. The same instance persists across tests, meaning one test can interfere with the results of another. It also hides dependencies. When code calls getInstance deep inside a function, you can't see the dependency from the outside. In many cases, dependency injection is a better alternative. It makes dependencies explicit and manageable. Instead of reaching out for a global instance, we pass the dependency directly into the function. Now the function signature tells you exactly what it needs, and you can easily pass a mock in your tests. Despite the criticism, singleton has valid uses, like logging services, config managers, or hardware drivers. It's perfect for controlled access to a shared resource that physically cannot or should not be duplicated. Just be deliberate. Don't use singleton as a crutch for passing data around. Reach for it only when genuinely needed. That wraps up the singleton and all 5 creational patterns. We've covered a lot of ground in this series. Next, we start the structural patterns with the adapter, which helps incompatible interfaces work together. It's like a power plug adapter when you travel abroad. See you there.